Now let's check the solution if you're not able to get it. The question says consider the expression a square plus a plus 1, b square plus b plus 1 and so on divided by a, b, c, d, e, where a, b, c, d, e are positive numbers, the minimum value of the expression, right? So if you remember that we have done the similar kind of question in our maximum minima algebra class, and if you do not remember, just look at the solution now. What we can do in this question, divide this expression with a, divide this expression with b, and so on. Divide this expression with e. So what do you get? If I divide this expression with a, what I'll remain with? I'll remain with a plus 1 by a. Similarly, if I divide this expression with b, what I'll remain with? I'll remain with b plus 1 by b, and so on. C plus 1 by c, and at the end I'll remain with e plus 1 by e. As it is given that they are positive numbers, so we know that any number and its reciprocal, the minimum value is 2. A number and its reciprocal, the sum of these two values is greater than 2 or equal to 2 with the help of am, get, and gm. We can prove it also. So the minimum value of this part, it's 2, 2 plus 1, it's 3. And similarly for all, 2 plus 1 is 3. So all the brackets have minimum value as 3. So what is the minimum value of this expression? The minimum value of this expression is 243. Answer. So simple question. Looks complicated. It is not. Or in this question, you can remember one more thing, alternative solution. In this kind of question where all the numbers are in same symmetry, a square, b square, c square, d square, and so on, what you can do, you can replace all of them with 1 also. Because this value comes out to be 2 when both of them are 1. So this is 1 and 1 by 1 is also 1. So if you want to find the minimum value, what you can do, you can replace this expression a, b, c, d, and e, replace with 1. So 1 plus 1, it's 3. 3 into 3 into 3 into 3 into 3. You will directly get the answer. Answer is 243. Okay, clear? So both the solution are correct. Either you can convert into the expression or you can replace it with 1. Okay, come to the next question. This is also simple. It is given that p raised to power q is equivalent to q raised to power p, and q is equivalent to 9p. So if I replace in this question p raised to power 9p, and that becomes 9p raised to power p. So can I cancel out p from both the side, or I can divide p both the side? So my question becomes p raised to power 9, it's 9p. I can further divide this p, or I can cancel out 1p from both the side. So the question remains p raised to power 8 is 9. P raised to power 8 is 9. What is the value of p? The value of p is 9 raised to power 1 by 8. Or you can write it, it is 8th root of 9. So answer is option 4. And you can remember this rule, if x raised to power a, it's x raised to power ab, then we can cancel out the common part from both the sides. Or we can say x raised to power c is x raised to power b. Right? That is correct. We have used the same property in this question. Look at the next question. All these questions are 2003 only. Now here it is given integers. If it is given integers, then obviously I cannot take it equal, because it is 10, and if I take it equal, I need to take 10 by 3, 10 by 3, 10 by 3. So here we want to maximize the product, and if sum is constant, the product will be maximum when all of them are equal. So in this case p and q should be equal, and here q and r should be equal, and similarly here p and r should be equal. So actually if p is equal to q and q is equal to r, so all three should be equal. But here I cannot take it equal, as I said, because it is given integers. So what we need to do, we need to take the close values, and it is non-negative means 0 or positive. So we'll try to get as close as possible values. So if I see 10, the three close numbers of 10 is 3, 3 and 4. You can take them in any order, answer will not change. These are the close values. 3, 3 and 4 are the close values. I cannot take 4, 4, 2. 4, 4, 2 will not be a close value. The closer value are 3, 3 and 4. So what is the maximum value? The maximum value of this product will be 3 into 3 plus 3 into 4 plus 3 into 4, 3 into 3 plus 3 into 4 and 3 into 4 plus 3 into 3 into 4. So the answer is 9 plus 12 plus 12 plus 36. 69 is the maximum value and the range is in between 60 to 70. So the correct answer is option 3. So the rule is again same, maximum value will be when they are equal. So all three of them should be equal, but here we cannot take equal, otherwise they won't be integers. So we have taken the close values. Okay, come to the next one. Now this is again a good question. The figure below shows the graph of a function. How many solutions does f of x equal to 15? So let's assume this as x. So first try to find for which value of this function this is equal to 15. As I can see, it is 15 at 4 and it is 15 at one more value, which is 12. So only at two places it is 15. So this is 15. If this value means f of x. F of x is either 4 or f of x is 12. Are you getting it? Because I have replaced this value with x, or you here, if you do not want to be confused, you can take it any other variable. Let's say it is k. So I replace f of x with k. So what is that k? That k is either 4 or k is 12. What is k? K is nothing, it is f of x. So f of x should be 4 or f of x should be 12. Now again, we need to do the same exercise. Now we need to check for which value of x, f of x is 4. So you can see f of x is 4. It's this value, is at this value, is at this value, and at one more value. So I can see the value of 4, it's coming out to be at 4 occasions. So from here I get 4 values of x. We need not to find what are the values. We can just say there are 4 values of x. Similarly, if I see 12, here it is 12. So if I see 12, I'll get at this value, and at this value. And there is no solution of 12 at this value. The graph is not extended here. Right? Graph is only given till -10. So can I say there are 3 more values for x? So 3 values from here and 4 values from here. So the question is, for how many values of x this is equal to 15? For 7 values of x, this is equal to 15. So correct answer is option 3. I'm sure this is clear to everyone. So we replace f of x with k. K is, we checked at which value of k it is 15. So 15 was at 4 and 15 was at 12. Then we again check for which value of x it is 4. So the y value, it's 4, is at somewhere at this value, at this value, at this value, and somewhere here. So at 4 values of x, y is coming out to be 4. And similarly 12, there are 3 occasions, 1, 2 and 3. So total 7 values. This is a good question.